Hey algebra folks, welcome back. So during this lesson, we're going to find another way to actually solve quadratic equations. So in our last lesson, we found out how to solve quadratic equations when we could just take the square root and find a real solution. But this time we're actually going to combine a skill that we've been learning since last trimester with what we know about solving equations, right? So we're going to use factoring in order to solve these quadratic equations now. So like I said, we can use the skills that we covered in trimester 2 and in assignments 2 and 3 to give us a second method of solving quadratics. So if a quadratic is in standard form and factorable by at least one of the methods that we covered in days 2 and 3, then we can find the solutions easily using the zero product property. And this is probably the most common way of actually solving quadratics. And just to recap some of the methods that we learned to factor, right? We learned GCF factoring. We also learned X method. We learned something called factoring by grouping. And then we learned one way to kind of group it all together with AC method. And then also remember that you can also combine really any of these methods together. Like another common form that we saw was combining GCF and X method together. So before we go into what the zero product property actually is, we just want to recap our standard form of a quadratic equation because that's really going to help us with our factoring skills, right? So remember our x squared is always the term that comes first, right, when we're writing in standard form. Our x term is always the second term, and then our constant term is always the last term. And in order for us to actually solve this equation, it has to equal 0. So if it doesn't equal 0, you need to subtract whatever this value is or add whatever that value is over here so that it equals 0. So let's look at this. So if we were given negative 21x plus 4x squared equals 18, right off the bat, I can tell that this isn't in standard form, right? I notice that my x squared term is actually second, and I notice that over here, my constant on the right-hand side of my equation isn't 0, it's 18. I need to change this to be a 0 so that I can actually solve this equation. So what I want to do is actually just subtract 18 on both sides, right? Just like how I did over here. And then I just want to rearrange the terms so that it's in standard order. So this 4x squared term should come first, this x term should come second, and then this constant should stay last, and this should all equal 0. So take a minute to just try this out on your own, right? Remember, the key things for standard form is 1, your x squared term comes first. And then the other term should follow. And then also your equation equals 0. Okay, so take a minute, pause the video here, try this out on your own. All right, you tried it out on your own? I feel like Dora the Explorer when I say that. But you tried that out on your own, let's try this out together, right? So right off the bat, I know that this isn't in standard form, right? Because I see that my x squared term is second, and my x term is first, and then this doesn't equal 0, right? So the first thing I'm going to try to do is actually just add the 16 on both sides so that I can get one side of my equation to equal 0. So I'm going to add 16 here, add 16 here. Okay, and then I notice that 16 is not a like term to any of these terms that I have on the left-hand side, right? So because it's not a like term, I'm not going to combine it with anything, so this is just going to be negative 6x minus x squared plus 16, and I know this equals 0, because that was the whole point of me adding 16 on both sides. Now what I want to do is just rearrange my terms, right? So I want my x squared term to come first, so I notice that my x squared term is negative x squared, so I'm going to write that first. Negative x squared, and minus 6x plus 16 equals 0. And that is my standard form of this equation. So now that we know what standard form is, which we definitely need in order to solve quadratic equations, we can actually then use the zero product property after we factored, right? So our zero product property is just a fancy way of saying that if you multiply two numbers or expressions together and it equals zero, then at least one of those numbers or expressions is equal to zero. So the definition is a little bit wordy, right? So let's look at an example. So let's say that I'm multiplying some variable z. I don't know what z is a variable for, like I don't know if it equals 1 or if it equals 4, right? I don't know what the value of z is. And I'm multiplying it with y, and similarly, I don't know what the value of y is. But I do know that when I multiply them both together, this equals 0. So because the product of anything times 0 is going to equal 0, we know that either y equals 0 or z equals 0, right? Because let's try out an example, right? Let's say that y equals 0. So if y equals 0, then I would have z times 0. And remember that 0 times anything is going to equal 0. So it doesn't matter if z is a billion or z is 0 itself, right? We know that z times 0 is still going to equal 0 because you're multiplying some value with 0. Similarly, if z equals 0, right? So instead of writing z times y, I'm going to write 0 times y. Similarly, I'm multiplying 0 times some number, right? So I know that this is going to equal 0 regardless of whatever that number is. So you might be asking, how can I actually use this in order to solve my quadratics, right? So let's say that I was given this factored equation, x plus 3 times x plus 2 equals 0. So when I actually multiply these out, I'm actually going to get the quadratic, right? So I can use the box method to multiply this out, but instead of making you do that, this should actually end up being x squared plus 5x plus 6 equals 0. You can actually verify that on your own time. But we had this original quadratic x squared plus 5x plus 6 equals 0, and I just factored it to be x plus 3 times x plus 2 equals 0. So when I'm using the zero product property to find my solutions, I just set each of my factors, x plus 3 and x plus 2, equal to 0. So I know, using the zero product property, that because I'm multiplying these two factors together and it equals 0, at least one of these factors is going to equal 0. Okay? So I know that x plus 3 could equal 0, or x plus 2 could equal 0. And then, after I set each of those factors equal to 0, I'm just going to solve for x, right? So the way that I solve for x is just by subtracting 3 on both sides to isolate my x, and then I get x equals negative 3. And over here, I did something similar, where I just subtracted 2 on both sides, where I got x equals negative 2 for my final answer. So these two values, just like how when we were solving for quadratics using the square root function, right? These two x values are actually solutions to our quadratic, right? So once again, in this case, our quadratic has two solutions. So remember that you will not always have two solutions, but then in this case, and in many cases of quadratics, you will have two solutions. So let's try out a check for understanding, right? You want to use a zero product property on this factored equation in order to solve for y, right? So take a minute, pause the video here, and just try this out on your own, and then when you're ready to check over the answer, press play again. All right, you solved it. Let's try it out. So using the zero product property, right, I notice that I'm multiplying 2y plus 1 and y plus 14 together. These are the two factors that I'm multiplying together, okay? So there have to be two cases or two equations that I'm setting up, right? Where one, this first factor is equal to 0, or this other factor is equal to 0. That's what my zero property tells me, right? So we can do 2y plus 1 equals 0, or we could do y plus 14 equals 0, right? This is another reason why it's so important to actually set our equation equal to 0, because if this value is anything other than 0, you can't just set your factors equal to whatever this value is, right? It's only for the special value of 0 that you can use the special property, zero product property, in order to actually set these factors equal to anything to solve, right? So if we go ahead and solve for y in this case, I'm just going to subtract 1 on both sides to get 2y equals negative 1. I'm going to divide by 2 on both sides, right? So I get y equals negative 1/2. If you write negative 0.5, that's also fine. but I like to leave my answers in fraction form. Over here, right, I'm just going to subtract 14 on both sides to get y equals negative 14. And that's my second answer. Right? So just set your factors equal to 0 and then solve for the variable because it just turns out to be a linear equation that we definitely know how to solve. So let's try to put all these skills together, right? Where we put together our factoring skills and then our solving with zero product property skills, right? So there's just one additional step to this process compared to our previous examples. So let's look at this problem. It asks us, what are the solutions of the equation x squared plus 8x plus 15 equals 0? Okay, so before you can even go ahead and start factoring, you want to first make sure that your equation is in standard form. So when I look at this, I see that my x squared term is first, my x term is second, my constant term is last, and then my whole equation is equal to 0. So that's exactly what I'm looking for. It's in standard form. I can move on. If it weren't in standard form, you would need to convert it to standard form before getting started. And you can look back to example 1 where we did actually convert these equations into standard form. Your step 2 is to actually factor using an appropriate method. When I look at this quadratic expression, I see that my a, b, and c are the following, right? So my a is my coefficient for my x squared term, so my a is 1, my b is 8, and my c is 15. Because I have a trinomial, right, I have 3 terms in this expression, and my coefficient for my x squared term, my a, equals 1, I know that I can use the x method, right? So when I use the x method, I put my c at the top, b at the bottom, and I want to find just one factor pair of 15 that adds up to 8. And I know that 5 times 3 multiplies to 15, and 5 plus 3 adds up to 8, so I found my factor pair. So once I find my factor pair, I can just write it out in my skeleton. So I have x plus 5 times x plus 3, and I set it all equal to 0 because I didn't do anything to that equals 0. So now I have a factored quadratic. And what I can actually do now is use my zero product property, right? Because I know that I have 2 factors multiplied together to equal 0. So I'm going to set my first factor, x plus 5, equal to 0. And then I'm going to solve for x on both. I'm going to solve for x by subtracting 5 on both sides to get x equals negative 5. And then on my right-hand side, I'm going to subtract 3 on both sides in order to solve for x to get x equals negative 3. And I set that x plus 3 equals 0 because I had my other factor, x plus 3, and I knew that I could set it equal to 0 using my zero product property. So in the end, my 2 solutions should be x equals negative 5 and x equals negative 3. So now's your time to try it on your own, right? Take a minute to just pause the video here and actually try to find the solutions for this equation, right? You want to make sure that you're following the steps to see if it's in standard form, factoring, and then using zero product property. So take a minute to just pause here, and when you're ready to check over your answer, press play. All right, you ready to look over your answer? Let's try it together. So when I first look at my equation, t squared plus 3t equals 54. So it looks like my square term is first. It looks like my my t term is second, right? The only thing is that my equation doesn't equal 0, right? And that's going to cause me some troubles. So before I can actually apply the zero product property, I need to make sure that my equation equals 0. So what I'm going to do is actually just subtract 54 on both sides of my equation so that I can get it equal to 0. Right, so I have t squared plus 3t. 54 is not a like term to t squared or 3t, so I'm just going to write it out next to it. And then this whole thing equals 0. Now it's in standard form, and now I can actually try factoring it out. So when I look at this expression, t squared plus 3t minus 54, I notice that my a is 1, my b is 3, and my c is negative 54, right? So because I have a trinomial, and my a equals 1, I know that I can use the x method, which is probably the easiest method to factor. So let's actually try out this x method, right? I'm going to draw big X, right? And then whenever I'm using my x method, I write my c at the top, my b at the bottom. I'm multiplying to my c, and I'm adding to my b. So my c, as I stated before, was negative 54. And then my b, like I said before, is 3. And remember, I put b at the bottom. Remember, b for bottom. And when I look at my c, I know that I need to multiply to negative 54. And when I think about what can multiply to a negative number, I know that there's only one option where you can have a positive and a negative factor pair. So I know that I'm going to be looking at a positive and negative factor pair of negative 54 because it's a negative and you can only have one combination of a positive and negative to multiply to a negative number. So when I think about what are some numbers that multiply to 54, right? I think about 1 and 54. I think about 2 and 27. 3 and 18. I know 6 and 9 multiply to 54. And I'm just going to stop there because I think that those are enough factor pairs for me to actually start investigating, right? So I know for sure that 1 and 54, I'm just going to cross it out because I know no combination of 1 and 54 being positive and negative can add up to 3. Same with 2 and 27, and then 3 and 18, right? But 6 and 9 might work, right? I know that positive 6 plus negative 9 is negative 3, so I'm actually just going to reverse them to be positive 9 and negative 6, right? So positive 9 plus negative 6 does give me positive 3. So it looks like I found my factor pair. So I'm going to use my factor pair in order to actually factor this out, right? So my factors were 9 and negative 6, so I have my skeleton here, where my variable is t, so I'm going to just put t in both of my parentheses. And then I know my two factors are positive 9 and negative 6, so I'm just going to write them for here. So plus 9 minus 6, and that's all equal to 0. Looks good. So now I can actually go ahead and use my zero product property. So I know because I'm multiplying these two factors and it equals 0, my first factor can equal 0. So t plus 9 can equal 0. But then also t minus 6 can equal 0 as well. So t minus 6 can equal 0. I'm just going to go ahead and solve for t in both of those. So I'm just going to subtract 9 on both sides to get t equals negative 9. I'm going to add 6 on both sides to get t equals 6. Looks like I found both my answers. So we should have gotten negative 9 and 6 for the t values. So if you have a function instead of an equation and you need to find the solutions, right, it's super easy. We actually already learned how to do this. So solutions to functions are called x-intercepts, where the graph hits the x-axis. Sometimes they're called zeros as well. So let's say that we had this function y equals x squared minus 4x plus 3. All we would need to do in order to solve for this function is just change the y to a 0, and then go ahead and use the skills that we learned about solving quadratic equations, right? So you can turn a function into an equation, and then just use those equation solving skills that we learned in order to actually solve the function, right? And remember that whenever you solve the function, you're just finding the x-intercept. So this looks like if you were to have this graph over here, and you were to have a parabola, your function would have solutions over here and over here, because that would be when your graph hits the x-axis. So these are your x-intercepts, your zeros, or your solutions, right? So go ahead and actually just, if for just your own practice, right, try to actually find the solutions to this function, right? You can actually pause the video here because I'm going to review it on the next slide. So let's say that you were given y equals x squared minus 4x plus 3, right? And so this is a function right now. I know that this is a function because I have two different variables, right? So in order to turn it into an equation where I'm solving for this, I'm just going to change this y to a 0. So I'm going to change this to 0 equals x squared minus 4x plus 3. Okay, now I have an equation, and I want to check to see whether or not this is in standard form. So is my x squared first? Yep. Is my x term second? Yep. My constants last? Yep. And then is this entire equation equal to 0? Check. So I don't have to put it in standard form. It's already in standard form for me. What I'm going to do next is actually try to factor this, right? So once again, I have a trinomial, and my a is equal to 1, my b is equal to -4, and my c is equal to 3. Because I have a trinomial and my a equals 1, I know that I can use the x method. So when I use the x method, I'm going to put my c at the top, my b at the bottom, and remember that I multiply to my c, add up to my b. So this is 3, and this is -4. And I want to find a factor pair of +3 that adds up to -4. And so the only combination of factor pairs for a positive number that adds up to a negative number is a negative and a negative, right? Because a negative times a negative multiplies to a positive, and a negative plus a negative adds up to a negative. So I want to think about my factor pairs of 3. 3 is a prime number, so the only factor pairs I have are -3 and -1, right? And let me just double check that this is going to multiply to 3 and add up to -4. So -3 times -1 definitely gives me +3. -3 plus -1 definitely gives me -4, so it looks like I found my right factor pair. So I'm going to actually factor this using my factor pairs. So I have 0 equals, and then my skeleton, my variable, and then my factor pairs, -3 and -1. So now I can actually use the zero product property where I set each of these factors equal to 0 because I notice that I'm multiplying these factors together and they multiply to 0. So I'm going to get x minus 3 equals 0 and x minus 1 equals 0. I'm just going to go ahead and solve for x, where I just add 3 on both sides to get x equals +3. I'm going to add 1 on both sides to get x equals +1. Add those x values on your graph, right? So at 1 and 3, this is where your parabola would pass through. So if you were to draw your graph, it would look a little something like this. So it's actually really important in order to be able to algebraically solve any quadratic functions you have, just because it would be pretty helpful in terms of actually figuring out how to sketch your graph without having to use a graphing calculator. So hopefully this was helpful. Now what you would want to do in order to practice the skill is actually work through worksheet number 12. And then in our next worksheet, we're going to be covering a new topic on solving quadratics.